Some structures should not exist. They were built where cliffs collapse, oceans attack, rivers push with billions of tons of water, and one small mistake could turn a masterpiece into a disaster. From highways carved into deadly mountains to bridges hanging above empty space, from nuclear plants beside the sea to canals that control global trade, these are the megaprojects where human ambition challenged nature at its most dangerous. Today, we're counting down the top 9 impossible megaprojects built on the edge of disaster. Stay until number 1 because the final project cost tens of thousands of lives village and still controls the movement of the world's oceans. Before we begin, tell us in the comments which one you would be most afraid to cross, enter, or stand near. Number 9. Karakoram Highway. This is not just a road through the mountains. It is a thin line of asphalt carved into one of the most dangerous landscapes on Earth. Picture a highway twisting between Pakistan and China, squeezed between towering rock walls, ice-covered peaks, and cliffs that drop into deep valleys below. The road clings to the mountainside like it was cut by force into the edge of the world. Trucks crawl through thin air. Boulders sit above the route like silent threats. Snow, landslides, and gravity are always nearby. From a drone shot, the highway looks almost unreal, a narrow scar across massive ancient mountains. The Karakoram Highway connects Pakistan and China through a region where construction was never supposed to be easy. Engineers and workers had to drill through solid rock, carve routes along unstable slopes, and build through terrain under constant geological pressure. The highest points of the route reach around 15,500 feet, where the air becomes thin and the mountains dominate everything. Building a normal road is hard. Building one through ice, rock, steep cliffs, and shifting terrain is something else entirely. This project matters because it turned one of the world's harshest mountain regions into a transportation corridor. But even today, it remains dangerous. The mountains did not stop fighting back after construction ended. The project took nearly 2 decades and involved tens of thousands of workers operating in brutal conditions. Landslides, falling rocks, and extreme altitude were not rare problems. They were part of the environment. That is what makes the highway so intense. It was not built through danger once. It lives inside danger every day. For the workers who built it, this was a battle against rock and weather. For the people who use it now, it is a lifeline for trade, travel, and connection between remote regions. But every journey across it still carries a reminder. This road exists only because humans refuse to accept the mountain's answer. But if the Karakoram Highway is a road carved into a mountain, the next megaproject is a city built from sand in the middle of the sea. From the high cliffs of Asia, we moved to Dubai, where engineers tried to turn open ocean into luxury real estate. Dubai did not just build near the ocean, it built land where there was no land. From above, Palm Jumeirah looks like a giant palm tree floating in the blue waters of the Arabian Gulf. Long fronds stretch outward from a central trunk. Around them, a curved breakwater wraps the island like a shield. Luxury homes, roads, hotels, beaches, and tunnels sit on what was once only seabed. It looks beautiful, but beneath that beauty is a massive engineering gamble. Sand pulled from the sea floor and forced to behave like solid land. Palm Jumeirah extends about 3 miles into the sea and created more than 1,400 acres of new land. Engineers pumped enormous volumes of sand from the seabed, shaped it into the palm design, and compressed it into a usable foundation. Around the island, a breakwater more than 10 miles long helps protect the structure from powerful sea forces. Without that protective barrier, the ocean would attack the reclaimed land constantly. The challenge was not just making the island, it was keeping it there. Reclaimed land must face waves, erosion, settlement, drainage, and long-term pressure from water. A normal city is built on Earth shaped by nature over time. This one was built on land humans forced into existence. The island includes an underwater traffic tunnel that allows vehicles to move between parts of the project. So the same megaproject includes artificial land, marine engineering, roads, homes, hotels, and submerged infrastructure. It is not one construction challenge, it is many stacked together. Palm Jumeirah became a global symbol of Dubai's ambition. It showed the world that engineering could reshape coastlines and turn the ocean itself into a real estate platform. But it also raised a deeper question. When humans create land from the sea, who is really in control? The engineers or the water waiting outside the breakwater? But building land in the ocean is one kind of risk. The next project placed nuclear power on a coastline where safety can never be treated casually. From artificial islands in Dubai, we moved to the coast of the United Kingdom and a giant energy fortress beside the sea. This megaproject is designed to power millions of homes, but it also sits on the thin boundary between energy security and extreme technological risk. On the coastline of the United Kingdom, massive cranes rise over a construction site filled with concrete, steel, tunnels, containment structures, and workers moving across a landscape that looks more like an industrial city than a power plant. From above, Hinkley Point C looks like a fortress beside the ocean. Heavy machinery moves constantly. Concrete walls thicken, reactor structures rise, and beyond the site, the sea waits just outside the industrial boundary. Hinkley Point C is a major nuclear power project designed with 2 EPR reactors. When completed, it is expected to produce around 3,200 megawatts of electricity, enough to supply millions of homes. The ambition is enormous, but so is the responsibility. Nuclear infrastructure demands layers of safety. Engineers must plan for cooling, containment, backup systems, emergency response, long-term operation, and scenarios that may never happen but still must be prepared for. The project includes multi-layer safety systems, including a core catcher designed to contain melted nuclear fuel in an extreme accident scenario. That detail alone shows the scale of what engineers must imagine. They are not only building for normal operation, they are building for the worst day. At peak construction, the site brought together more than 22,000 workers. The total investment exceeds tens of billions of pounds, placing enormous pressure on cost control, technical reliability, and safety. Every delay matters, every system matters, every mistake matters. Because this is not a small building that can simply shut its doors if something goes wrong. It is national energy infrastructure. For the United Kingdom, Hinkley Point C represents a promise, stable low-carbon electricity for millions of homes. But for engineers, it represents something much heavier, the challenge of controlling nuclear technology for decades, beside a changing coastline and a complex natural environment. But as dangerous as a nuclear megaproject can be, our next structure had to stop an entire river before it could be built. From a nuclear fortress by the sea, we moved to the American desert, where workers carved into canyon walls to build one of the most famous dams on Earth. Hoover Dam did not just control a river, it forced one of America's wildest waterways to obey concrete. At the border of Nevada and Arizona, the Colorado River cuts through a deep canyon of desert rock. Rising between those canyon walls is Hoover Dam, a massive curved wall of concrete standing more than 700 feet high. From below, it looks like a man-made cliff. From above, the reservoir presses against it like a silent ocean trapped in the desert. Workers once hung from ropes on the canyon walls, drilling, blasting, and clearing loose rock that could fall onto the construction site below. Hoover Dam was one of the great engineering challenges of its time. Before the dam could even rise, engineers had to redirect the Colorado River through enormous diversion tunnels. That means they had to temporarily move a river out of the way so they could build the wall that would eventually control it. More than 4 million cubic yards of concrete were poured into the structure, creating a mass strong enough to hold back millions of tons of water. But the risk was extreme. A mistake in the diversion work could flood the construction area. A rockfall could kill workers. A failure in the dam after completion could release catastrophic water downstream. More than 20,000 workers were involved in building the dam, many operating in brutal desert heat and dangerous canyon conditions. The dam's base is more than 600 feet thick. That is not just architecture. That is a concrete mountain built to resist a river. Hoover Dam transformed the American Southwest. It generated power, controlled floods, supplied water, and became an icon of engineering ambition. But it also shows the human cost behind megaprojects. Before the clean tourist photos and postcard views, there were workers drilling rock faces while hanging above danger. But Hoover Dam controls one river. The next project placed a highway across the ocean, then forced it to disappear beneath the sea. From the desert canyons of America, we moved to China, where a bridge, tunnel, and artificial island system became one of the boldest sea crossings ever built. This is not just a bridge. It is a 30-mile machine crossing the open sea. Imagine driving across a highway surrounded by water on both sides. The road stretches forward like a runway over the ocean. Then something strange happens. The highway begins to descend. The bridge disappears. You are no longer above the sea. You are no longer above the sea. You are inside it. The Kong-Zhuhai-Macau bridge combines long sea bridges, artificial islands, and an underwater tunnel, all working together in one massive transport system. The sea crossing stretches more than 30 miles, linking Hong Kong, Zhuhai, and Macau. To keep space open for large ships, engineers could not simply build one continuous bridge across the entire route. So they designed a section where the roadway dives into an underwater tunnel. Inside the submerged section, 33 massive concrete tunnel segments were joined underwater. Each had to align with extreme precision because even a small error could create serious consequences. This is what makes the project so intense. It is not one engineering problem. It is bridge engineering, marine construction, tunnel engineering, traffic design, navigation safety, and foundation work all merged into one system. During construction, investigations reportedly revealed suspected falsified concrete test results, turning the project into a reminder that megaproject danger is not only natural. Sometimes the greatest threat is human error, poor oversight, or compromised quality control. When a structure carries people across and under the sea, trust in testing is not optional, it is survival. The bridge shortened travel between major cities and became a symbol of regional connection and economic ambition. But for every driver crossing it, the hidden story remains below the tires: deep foundations, underwater joints, marine pressure, and the constant battle to keep a road stable in an environment that never stops moving. But if this bridge challenged the sea with concrete and steel, the next megaproject challenged one of the most powerful rivers in the world. From a sea crossing in southern China, we move inland to the Yangtze River and a dam so large it reshaped the landscape behind it. We're halfway through, and every project so far has pushed engineering into dangerous territory: mountains, oceans, rivers, and nuclear systems. Which one feels the most impossible to you so far? Drop your answer before we reach number 1. This dam is so massive that it does not feel like a structure. It feels like a concrete horizon placed across a river. On the Yangtze River in China, Three Gorges Dam stretches across the water like a giant wall. The concrete face runs almost 8,000 feet long and rises nearly 600 feet high. Behind it, a vast reservoir extends for hundreds of miles. The water looks calm from above, but that calm is deceptive. Billions of tons of water are pressing against the structure every second. Inside the dam, turbines spin continuously, transforming river force into electricity for millions. Three Gorges Dam is one of the most powerful symbols of human control over nature. It blocks the flow of the Yangtze River and converts an enormous water system into electricity, flood control, and navigation infrastructure. But the scale creates serious risk. The larger the reservoir, the larger the pressure. The more people depend on the system, the more dangerous failure becomes. A small technical problem in a minor structure may affect a neighborhood, A serious problem in a megadam can affect entire regions. This is why dams of this scale require constant monitoring, maintenance, and control. The reservoir stretches close to 400 miles, creating an artificial water body so large it changes the geography around it. Behind the dam is not just water. It is stored force, a gigantic weight held in place by engineering, inspection, and trust. Three Gorges Dam powers huge numbers of homes and supports national infrastructure. But its construction also transformed communities, landscapes, river systems, and local life. For many people, the dam is progress. For others, it is a reminder that controlling nature often means reshaping human lives too. But Three Gorges holds back a river. The next project was built because an entire nation had to defend itself from the sea. From China's river giant, we moved to the Netherlands, where survival required building a national-scale shield against ocean water. What happens when a country realizes the sea could return at any time? It builds one of the greatest defensive systems on Earth. Along the coast of the Netherlands, storm surge barriers, dams, gates, and protective walls stretch across water channels like mechanical fortresses. Huge steel barriers sit ready in deep water. When the sea rises, they can lower into position, turning open water into a controlled front line. From above, Delta Works looks less like a single project and more like a national machine built to hold back the ocean. Delta Works was born from disaster. After the flood of 1953 killed 1,836 people, the Netherlands began constructing a massive system of sea defenses. It is not one dam. It is a network of dams, storm surge barriers, gates, and protective structures designed to control powerful seawater flows. The system stretches for nearly 19 miles and includes 13 dams along with enormous gates. This is engineering as survival, not luxury, not speed, not prestige, survival. Some barriers can remain open during normal conditions, allowing water, ships, and ecosystems to function more naturally. But when dangerous sea levels rise, the gates can close and transform the coastline into a defensive wall. That balance is what makes the project remarkable. It does not simply block the sea forever. It negotiates with it. For the Dutch people, Delta Works is more than infrastructure. It is memory turned into concrete and steel. The 1953 flood was not just a historical event, it became a national warning. Delta Works is the answer, a declaration that the sea may be powerful, but it will not be allowed to decide the country's future without resistance. But even a national seawall feels different from the next megaproject, a bridge so high that cars seem to float above an empty canyon. From the battle against the ocean, we moved to China, where engineers suspended a road thousands of feet above the valley floor. This bridge does not just cross a valley, it crosses open air. High in the mountains of China, the Duge Bridge stretches between steep cliffs like a steel thread pulled across the sky. Far below, the valley floor disappears into distance. Vehicles crossing the deck look tiny, almost like insects moving across a line suspended between mountains. The bridge deck stands about 1,800 feet above the valley floor, close to the height of a building more than 180 floors tall. From the driver's seat, the world opens on both sides. There is road beneath you, but everything else is empty space. When it was completed in 2016, the Duge Bridge became the highest bridge on Earth at the time. It stretches about 4,400 feet and turned a journey that once took hours into only minutes. To build it, engineers anchored giant towers into steep mountain slopes and pulled massive steel cables across a huge gap. That sounds simple when spoken. It is not. Every tower had to transfer enormous forces into difficult terrain. Every cable had to carry load across open space. Every section had to resist wind, vibration, weight, weather, and long-term stress. A bridge this high is not just fighting gravity. It is fighting the environment around gravity. From far away, the bridge looks almost delicate, a thin line between cliffs. But in reality, it is a vast steel structure weighing tens of thousands of tons. That contrast is what makes it terrifying. It looks like a thread. It carries the weight of a megaproject. For local communities, the Duge Bridge dramatically shortened travel time and improved connection through a difficult mountain region. But for the engineers and workers who built it, the project was a vertical challenge: cliffs, cables, towers, weather, height, and the psychological pressure of building above a void. But as extreme as Duge Bridge is, number 1 is older, deadlier, and more important to the modern world than almost any megaproject on this list. For the final project, we leave the mountains and go to Central America, where humans cut a path between 2 oceans. Number 1 is the Panama Canal, a megaproject so dangerous, so ambitious, and so important that it changed global trade while costing tens of thousands of lives. Imagine standing beside a massive concrete lock as a container ship enters the chamber. The vessel is enormous, longer than a city block, stacked with metal containers, carrying goods from one side of the world to the other. Then the gates close. Water begins to rise. Slowly the ship lifts, not with a crane, not with wheels, but with water itself. The Panama Canal works like a giant elevator for ships, lifting and lowering entire floating cities through a narrow passage between the Atlantic and Pacific Oceans. On both sides, the walls are tight, the movement is slow, the margin for error feels almost non-existent. A ship is not just passing through a canal, it is being threaded through one of the most important machines on Earth. The Panama Canal cuts across the narrow land of Central America and links the Atlantic Ocean with the Pacific Ocean. Before it existed, ships had to travel around the southern tip of South America, a much longer and more dangerous route. The canal changed that. It shortened global shipping routes and transformed maritime trade. But building it was almost unimaginably difficult. Workers had to cut through jungle, rock, mud, disease, heat, unstable ground, and water systems that fought the project constantly. The canal stretches about 40 miles, but its influence reaches across the entire planet. Every ship that passes through it depends on lock chambers, gates, water levels, navigation control, and timing. One failure can create delays. One accident can disrupt trade. One breakdown can affect supply chains far beyond Panama. During the construction period, disease and accidents claimed the lives of about 27,000 workers. That number changes the way you see the canal. It is not just an engineering marvel. It is a monument to human cost. Every clean aerial shot hides a darker history underneath. Workers lost to disease, collapse, exhaustion, and the brutal conditions of building a passage through one of the most difficult environments on Earth. And more than a century after opening, the canal still operates as one of the world's most strategic shipping corridors. The Panama Canal matters because it proves how infrastructure can reshape civilization. It did not just connect 2 oceans. It changed military strategy, changed trade routes, changed shipping economics, changed the way nations moved goods, resources, and power. It became a shortcut for the world, but it also showed the price of forcing geography to bend. The canal is a reminder that some megaprojects are so important they become invisible. People buy products, ship goods, and depend on global trade without thinking about the narrow strip of water that made it faster. Yet behind that convenience is a machine that must keep working. Every gate, every lock, every water level, every vessel moving through the channel. That is why the Panama Canal deserves number 1. Because it is not only huge, it is not only dangerous, it is not only historic, it is a megaproject that turned Earth itself into infrastructure. Humans looked at a continent and said, "We will cut through it." They looked at oceans and said, "We will connect them." They looked at distance and said, "We will shorten it." But nature did not give that victory freely. It took lives. It took decades. It took engineering, sacrifice, failure, and persistence on a scale most people can barely imagine. Today, when a ship rises inside the locks, it looks smooth and controlled. But beneath that calm movement is one of the most extreme engineering stories ever told. The Panama Canal is not just a shortcut. It is proof that when human ambition reaches far enough, it does not simply build on the planet. It rewrites the map. Megaprojects like these reveal something strange about humanity. We build roads where mountains collapse. We build cities where the sea used to be. We build dams against rivers, bridges above empty valleys, barriers against oceans, and canals through continents. Every one of these structures is a victory, but every one is also a warning. Because the bigger the project, the thinner the margin. One bad calculation, one hidden weakness, one storm, one earthquake, one maintenance failure, and a masterpiece can become a disaster. Which megaproject shocked you the most? Was it the bridge in the sky, the artificial island, the nuclear plant beside the sea, or the canal that connects two oceans? Let us know in the comments and subscribe for more cinematic rankings about the most extreme places, constructions, and mysteries on Earth. In the next video, we'll explore megastructures so dangerous that engineers still worry about what could happen if they failed.